This is JS Programming 2, Module 5, Lecture 1 of 2, and we're going to talk about application patterns. So I'm your instructor, Robert Hewlett. You can contact me via Gmail or Twitter. The general learning outcome is to master, know and understand all content and concepts discussed in lab, lecture, and the assigned readings. Specific learning outcomes, although not absolute, describe the MV design pattern, describe the MVC design pattern, describe the MVP design pattern, describe the MVD design pattern, describe the MVVM design pattern, describe the JavaFX user interface design pattern, describe the HTML5 user interface design pattern, and describe the QML user interface design pattern. First, I'm going to talk about MV. So what is MV, right? M is for the model. That usually means data. I guess when we first build apps, we get back to train up a little bit, is we actually don't separate anything. Our code is a big custom mess. We write code specifically to solve a particular problem, and so we don't spend a lot of time teasing apart the code from the data source that it's operating on. It's just one big blob, and it works fine. But after typically building several applications, there's things that you do with data that aren't seen on the screen, and then there's things that are seen on the screen, right? And it's a different world. The database is worried about rows and columns. The interface is, spinners and buttons and drop-down lists. So before we even get to the M and the V, right, it's usually just one big chunk of code. But over time, people start to separate things out and try to streamline the process or build frameworks around certain areas of the program. The view part that the user sees, the storage part that the operating system sees, or the back-end databases and that. And so they start to separate the two to see if they can sort of handle them better. It also allows you to future-proof your app. What we find is data stores don't change as fast as front ends. We've gone through lots of cycles on the desktop, on the web, on a mobile device, and relational databases has basically been rows and columns for 20 to 30 years. And so that back-end part, the model, doesn't always change. Now, to be honest, there's lots of different layers now in the back end, so there can be lots of different models as well, or models on top of models on top of models, that eventually get to some system that's responsible for saving the data to disk somewhere. Even a hosted feature service in ArcGIS Online, eventually those changes you make have to be written to disk in some system. So M is for the model. The model is the data, right? It's the data for your app. One that we should be familiar with is the feature set. So this is a way to move spatial data around. It's not the end all or be all, but it's a very common thing you'll run into in the JavaScript API and a lot of the runtime APIs, this thing called the feature set. Okay. Even data for a button on a UI can be stored in a model. So sometimes this is applied across the big A application, right? These techniques of separating data from data storage and how that's managed versus data presentation, how it looks. So this could be for the big picture, the whole application, right? All of the application's data, how is it stored, like the geodatabase, and then how do we view it? ArcPro, ArcMap, ArcScene, on the web with JavaScript in a browser. So, but it can also be applied on the micro level, right? Just for a button. So there's this visual component called a button on the screen. That's something that a user sees. But a button has data. How is that stored? So sometimes we have to be careful when people talk about these design patterns. Sometimes they're talking at the control level. They're talking about how their buttons work, how their drop-down lists work. Some people see that pattern happening and they say, hey, that's a good idea. Maybe I should apply that to the whole application, right? And separate how I store the data. And Easter has done this over the years, right? How we store the data, geodatabase, whether it's file or enterprise, it's the same kind of schema, same kind of model. Very different views in terms of the browser, ArcMap, Explorer for ArcGIS, Collector, right? ArcGIS Online, all these ArcPro, all these are different ways of viewing the same data. ArcGIS Server, right? Another way, right? It's almost a model on top of a model. Yeah, the data is eventually stored in a file geodatabase or an enterprise-enabled geodatabase, but it's presented to you as a REST service, which is kind of like switching the model or transforming the model into another model that the web understands, REST. But it's still not something that we visualize until we, have a map control either in a desktop or in a web page that can show you the tiles or show you the vectors that come from the services, right? So we do have models on top of models, but it's this separation of data storage and that, and even data formats, right? And flipping formats from us, what the user sees, a blue dot on the screen. Okay, so this can be applied at the macro level across the whole application, micro level for an individual control such as a button, because even buttons have data. The text that's displayed may be different colors when you hover, the button's appearance when it's depressed versus released, so or toggled, that sort of thing. Today, I guess buttons are slid to the left and right more than that they are clicked on. And so, even the data for a button can take on this model approach. But it is this, instead of it being one big mess, right, of code and data all intertwined, let's separate that out a bit, right? It might help us out. Tune the data to be data, tune the view to do view things. And so, again, M is for the model. The model is the data, right? So how the data is stored or represented relationally, graph, that sort of thing. And as I mentioned, the data for a button, am I off, am I on, right? V is for the view, right? What the user sees on the screen, which could be very different, right? So although we're coming back to it in some of the HTML5 and cascading style sheets, and we're coming back to it on the mobile devices, the controls are getting better, I would say, or more, intuitive or unchained, right? And so there was this period in Flash and with Flex Builder where we had these models and we could apply any type of skins for the controls. So if you wanted them to be buttons or menus or like a little slide out drawer with a handle that someone pulled on, how that looks to the user or how the user interacts with a control on the screen. Do they click it and it drops a list down, or do they spin it? Do they flick it? Do they swipe it? That sort of thing. And then the animation and the effects and the control itself. Is it, does the user type in a number, or do they spin a little dial to set the number? So there's lots of different ways to present an interface to the user to get them to set a number, right? But the view is what the user sees on the screen. And you can see this in a video later with insights, is when the data comes in, there is this model, but do you want to see it as a map? Do you want to see it as a table? Do you want to see it as a chart? Right, so that's a different view on the same model, right? And that's another thing too, is that by clearly separating the model from the view, we can have multiple views on the same data. Okay, when it's one big chunk, right? And I've written code like this. This is how you start out. It's normal. You write it as one big chunk. It's very hard to have a different view of the data because it's all intertwined and braided together. It's a mess. But when you adopt these design patterns, and sometimes they're forced upon you, you do have this ability when you break the model from the view to have multiple or different views of the same data. So like I said, data as a chart, data as a table, data as a map, right? Right? How does the button look when it's slid to the left, slid to the right? Often, not always. These are toggle buttons. So to the left, they'll show it grayed out, and slid to the right, which means on, the colors change and all that sort of stuff to visually make you aware that it went from sort of some off state to on state, like where it's lit up. Like I said, sometimes there's no separation, right? Messy, 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 right? Hot, sticky mess indeed, right? So very hard to take that program and reskin it so that it looks, to just reskin some controls or reskin the app because it's all one big mess. You would have to rebuild it, the whole thing again. Right? So eventually, if you have an app, right, you typically need to store your data, right? Maybe you don't. But a bigger one where you're letting users draw things, edit things, you eventually have to save stuff. And if this is all just one big chunk, very hard to change the view over time or have a different view. So a lot of pain when you don't separate it. But when you first start out, you typically do make a bunch of hot, sticky messes. So the normal case for a GS developer, the data for us when we work with it is clearly separated. The data is in a file geodatabase or an enterprise-enabled geodatabase. We're kind of aware that the data is coming from somewhere, shapefile, right, CAD file, that's the data, the model, right? Now we might stack models on top of models, take that shapefile, take that geo package from the OGC, take that CAD file, right, and abstract it as a REST service. But that's still a model, right? That's just a different way to represent the data. Good, right? And that sort of thing. Right? So, like I said, for us, the model beats us up all day long, so we're very aware of it. Limitations in shapefiles and geo packages and feature services and OGC web feature services, or the feature set, the feature class, the file geodatabase, the enterprise-enabled geodatabase. So okay, we get it. Okay, no, the data's over there. That's how it's stored. And how we look at it in ArcMap, ArcPro, on the web, well, that's different, right? Then it becomes dots and lines and polygons, right? Or maybe it's in Mapbox vector tile format, which is very popular. So even though we may have a model for storage, like I said, we sometimes stack models on top of models. We still need a model on the software side to even abstract all of those different things above, typically as one thing, a feature, right? And so one thing that the Israeli geodatabase does is provide application logic or a separation from the physical reality. Was that a directory? Was that a shapefile? Was that a database? Doesn't matter. What you don't know won't hurt you. For you today, it's just a feature, right? That's all you need to know. You really don't need to know where it came from. Maybe it came from somewhere, not even from a file. Maybe it came from an OGC service. But eventually, I'm not going to tell you lies here right now. Everything is stored as a file on disk somewhere eventually. But there's different ways to, even on the model side, represent that data to a consumer, an application. So view examples, the normal case for GS developers. We grew up with the geo-relational model. The map is omnipresent, right? So one thing about the geo-relational model, a model on top of models. So we have all those data model formats, right? Shapefiles. And then there's the whole geo-relational thing where there's going to be features on the screen. And with a right click, we can usually get to the attribute table for those features. So the data on the features is represented as a two-dimensional model. But is this georelational sort of back and forth? There is a map with things on the screen that are symbolized. A click away is the two-dimensional row and column version of that same data. We may have been taking advantage of that or just accepted that as the thing and never dive deeply into it. But so we've had these storage models, file shape files, coverages, geodatabase, and then we've also lived in this model on top of a model, the georelational model, where all those whatever they were get abstracted as rows and columns, two-dimensional, right? That's how we traditionally deal with it in QGIS, ArcMap, ArcPro, right? Right-click away is this table that we can query and filter and use to zoom around the map if we select a row, that sort of thing. The map, we might take it for granted, but that is a different view of that model stacked on top of a model. The map is the one thing we're always trying to hook into. So when you're developing on the web or developing on the mobile device, you usually have to talk to the map, right? Or the map view to slide in some graphics or graphics overlay or turn on and off a layer, right? Or get to a layer in the map to get some information. So sometimes that one view of the data is the data as a map, right? The data as a chart, like in the dashboard, or the data as a gauge. So sometimes you can take that data and I just need to count how many trees are in my current view. Data as a table, so rows and columns, the georelational, the relational side coming up here, right? So Insights is a great way where this is upfront in your face when you first drag some data onto the screen. How do you want to see that? Map, chart, table. So what you can do now is pause my video lecture and watch this video from ESRI, and it gives you a good overview of Insights. It's got some interesting background techno music, but notice as they bring the data in from the services, right, or from layers in ArcGIS Online, look for the little graphic that comes up that has the three views. How do you want to see this? Map, table, chart. So a dashboard video will be coming soon. So what I want to do now is expand on the model view, right? So let's say we promise to ourselves whenever I can, if I make a bigger application, that I will look further into separating out the data from how we view it, and maybe even start using some frameworks that already do this for us, right? It adds a level of complexity, but there's some serious payoffs for doing it this way. So instead of bundling all of our stuff, the view and the data, in one big hot sticky mess of code and data that's really hard to future-proof, right? Design in a way that we can easily change the front end from the back end, right? But we're going to look at one of the original patterns that a lot of the others branch off of, called Model View Controller. Okay, and so first, before we got here, Model View Controller, I had to get to the concept of there being a model and a view. So what's new? The controller, the C part. Okay, so if we accept, okay, no, MV, model view, good thing. Okay, so separating how we represent or look at the data, right, from the model. It also allows us to have different views on that data, something that we probably, in all honesty, right, it's just taken for granted. It's always been there with QGIS and ArcMap, ArcView and ArcPro. It's always been there, right? Right click, I'm a right click away from the table, but that is just a different view of the data. So in this MVC pattern, we're going to have a model, we're going to have a view, but there's this new thing called a controller. Okay, and have we seen a controller before? Well, if you took 7010 with me, yes, we have, right? So in JavaFX, when we use Scene Builder, right, There's ways you can get around not having a controller. But if you use JavaFX and we use Scene Builder, there's a very distinct separation between your code, right, and the view. So the view is actually stored in a different language, that sort of thing. So main stage was a wrapper class that just launched the user interface, the view, right? Main stage FXML, that FXML gets turned into what the user is going to see on the screen, the menus, the dialogues, the buttons, the canvases where the maps are drawn. But then there was this main stage controller that the view talked to, right? And so even in code, so when you use JavaFX with Scene Builder and you use FXML and all the @FXML tags to do the control injection and that sort of thing, then you're entering into this world, whether you knew it or not, that separates out the view, right? And it can be spec'd out in a different language from eventually the data. What happens here a lot in this framework, done this way, is that the view starts to get some distance between it and the model, and it talks a lot to the controller. So someone does something on the view, a swipe, a click, a drag, and that causes an event to happen, and we have some code that responds to that in the controller. All right. So where's the model? Well, the question is, I have to ask, well, where's your data? And then we can talk. And are we talking the macro level? Are we talking the concept of data for your whole application? Or are we talking, the data just for one particular control? So the micro of the macro, whole application, versus the micro, data just for one control. Okay. So where's the model? That'll depend on where your data is. And maybe you're taking advantage of MVC and maybe you're not, right? When you first start out programming, you're just trying to figure out variables, ifs, and loops, right? Framework patterns is for another day. Well, now it's that day, and we'll talk a little bit more about them. So where's the model in this case? Well, it depends, right? Where's the data for your app? How did you bring it in? If you just open it up and brought it into memory and put it into sort of an array list, that would be your model. You made it on the fly quickly, but definitely your data is stored in some array list somewhere, and maybe you took advantage of the properties that are built in JavaFX, and so there's via the controller and the properties, the drop-down list is sort of synced to whatever you had in your array list, or the objects in your array list. So it all depends what you did with your data, right? If you took advantage of someone else's classes or you built your own. But typically in the model view controller, right, the user sees the view, that's what they click on. And typically by clicking on that, that raises events which are handled by methods in the controller, right? And based on that, maybe we load some data, change some data, edit some data. And then when the model, when the controller applies those changes to the model, the data, say your array list, then your view gets updated. If you're taking advantage of these things that are built into the language. But this is sort of how it works, is the user talks to the view, the controller does the work, the model changes, and then the model updates the view, the thing that the user was looking at. This pattern is good for on the desktop, I'll say, or where things are fast. And when we say desktop, we have to realize that mobile devices, whether it be phone or tablet, it's like building a desktop application. So a lot of them follow, or try to, if you're using a larger framework, this MVC pattern at least. And then they might take on one of the variations of this pattern. But that's typically how it works, is you interact with the view, which causes the controller to handle those events, which then, if you're doing edits to the data, changes the model. And if the model has properties synced with the view, then you'll see things change on the view. Little round tripping there, just so you know. Okay, and so that's sort of one of the base patterns that you have to get put as your foundation, because then all the other ones say we're kind of like MVC except we change this one part. Okay. And so there are some MVC frameworks on the web. These are, I want, it's not an absolute thing, but it's typically uh, where you have a lot of full page refreshes. And so what happens is the view's way up in the browser. You do some things that change that gets sent all the way back to the server. Based on that, the server generates a new page and shoots it back out to the browser. Right? So that's you eventually changing the model sending new HTML and cascading style sheets and JavaScript to you, and something changes. What you find with these pages is that, there's a little bit of a thud, half second, quarter second blink that you can kind of notice sometimes, and then the whole page refreshes, and that's okay, right? Right, but there's still people trying to use MVC across the web. The problem is the web uses the internet. The internet is basically network, and anytime you do stuff over the network, it's slow compared to doing it local on a device, on a tablet, on a phone, on a desktop, right? So early model view control over the web, like I said, a lot of full page refreshes. Think map server with this map file. You send in where you clicked and an HTML template. It processes that in the background, right? So the controller would be like back on the web server. It generates like a new view, shoots that back out to the browser, and the contents in the DOM change. Okay. So if you took 7132 with me, you just think of Mod 5 when we were labeling some maps, but with with PHP, because that's sort of how PHP kind of works, right? You change stuff up in the browser and that'll get sent through a post or a get back to the server. The server does a bunch of stuff and sends you a bunch of brand new HTML and cascading style sheets in JavaScript. Even modern frameworks can still use MVC, right? All depends what you're attempting to do. Django is built that way. Ruby on Rails is built that way. ASP.NET has an MVC framework. And that's another thing too, is that frameworks decide on the pattern, not so much languages. Languages are at a foundational level that allow you to create different types of application patterns. So the language doesn't dictate whether it's MVC, but a framework that someone built for a language might. And so Django Rails and ASP MVC are definitely frameworks for for languages. Okay, Django is a Python thing. Rat would be the language. Ruby is the language for Rails, and with .NET, it's either C# or VB.NET. So with a web page, if the HTML client is really thin, then they typically have a super thick, we'll say, model view controller server on the other side. So what that means is not much is being done up in the browser, which means you have to go all the way back to the server to figure things out, business logic and that. And then your question might be, well, what about products such as Java server pages, PHP, ASP.NET? A lot of those are, I call them round trips. You got to go all the way back to server, back on the server, the controller figures some things out, updates the view, and then the new view is sent typically all the way from the back end all the way up to the front end. It may or may not involve a full page refresh, but back in the day, that's how it was done. So what we're going to talk about now is MVP. So it's a variant of MVC. So it's meant to be a little bit of an adjustment, tweak, might be the best way to describe it, of model view controller, but model view presenter. So what's new? So this thing called the presenter. C goes away, replaced by P, the presenter. And I call it the monkey in the middle, that sort of thing. So the difference is the model does not directly update the view. So before we had this round trip where we went all the way back into the server, and then the model updated the view, and then the view is kind of forwarded right from the server to the browser, right? And so the model doesn't directly update the view. So there's this thing in the middle that does it. So everything runs through the presenter. Now, the presenter could be server side or client side. So now you have this option, right? You could put it all the way back on the server like we did before with the controller, or you could have it all the way up on the front. So if you want a really responsive application, then typically, you want to push that all the way to the client side so it can respond fast in that. So what do you get? Clear separation of the model and the data. That's one thing that happens. Before, because it went all the way into the back end, and I told you before, hot sticky mess. So sometimes if you go all the way back to the server, sometimes that code's not as clean as it could be in terms of separating the model and the view. Definitely when we go model, view, presenter, there is this monkey in the middle. There's even further, clear, more distinctive separation between the view, what the client typically sees, you, the end user, as well, versus all the way back on the server, which may have, say, in ArcGIS Inline case, services, and even in behind that, even more model, say it's geodatabase, and even behind that, even more model, because it might be stored in a relational database such as Postgres, Oracle, or SQL Server, and that sort of thing. And so you get really clear separation between model and view, right? And so then what is the trick? One thing is that this presenter in the middle gets involved a lot with what we would call on the desktop, because where you see model, view, presenter used a lot is in the web. But it kind of tries to mimic how we used to do the desktop with events, the event paradigm, and what QML calls signals. But then what you see is these AJAX calls and a lot of callback. I call it callback city, where things shoot off back in the server, and whenever they figure themselves out, eventually the presenter will forward all the information to the view, and the user will see the result of their clicking, swiping, and that sort of thing. So it's a little bit different. They call it a passive view because sort of the updates are forced into it by the presenter, right? So the presenter sits in the middle, and so it clearly cuts off, separates the model from the view. Where in before, because we tied all the way back into the back end, and there's still a little bit of that hot sticky mess I talked about, where your code and your data is kind of bundled and it shoots a new view out. No, we really tease apart that there's this presenter in the middle, and it's responsible for updating the view and listening to the view, people clicking, swiping, selecting choices in the drop down list, and then it goes back to the model, gets the changes, and potentially or not, reorganizes those changes and sends them to the view, right? So that's why I call it monkey in the middle, right? Because there's this presenter class that definitely cuts off the view and the model. So little caveats: what makes something micro view controller, model view controller versus model view presenter? Basically, is some subtleties, but they can be profound in that. So it's not the language. I just want to drill this point home. So it's not whether you're Java or whether you're ASP.NET. Some people, they really get it muddled and mixed up. So the language actually has nothing to do with it. It's you using the language with a application pattern or design pattern. So do you want to use the language as MVC, or do you want to use the language in more of an MVP style, right? And that. And so it's not that it's Java or JavaFX or JavaScript forcing this MVC versus MVP. It's the framework. So the framework that you either develop yourself, which is it's not unusual, just rare, or is it the framework that you're using, right? I'm using Django, or I'm using Angular, right? So it's typically the framework that makes that determination, whether something is following the pattern of MVC or MVP, right? And so it's how you sort of organize your code. Right? And so there's that problem where sometimes framework and languages get grouped together. It's really hard to separate something like Ruby on Rails. I mean, it's so glued together. It's really hard to separate the Django from Python and that. But there is a separation, right? One thing is a language and the other thing is a framework. And so it's the framework that really determines the design pattern. And so within a language, you can have many design patterns. It really depends how many people have built frameworks for that language. Right? And if you're a popular language, there'll be lots of frameworks, right? And so the idea that framework and languages are grouped together is one thing. The reality is, well, they're not. A language is a language and a framework is something else. It may be that like a lot of things in Node with the Express and Jade templating borrows a lot from Ruby on Rails, so that style of framework. Okay. So this is sort of a view, how to compare micro view controller, micro view presenter. Just remember that with the presenter, there is definitely a monkey in the middle, and the model is very distinctly and clearly cut off from updating the view. The thing is that back in the day, the model and the controller, if they weren't clearly teased apart in MVC, you could have the model directly updating the view. The model view presenter tries to get away from that. And where we see that a lot is in the web. And that is having this middle tier or middle layer that separates someone in a browser versus some back-end database hidden even behind a REST service. So we're talking about MVD, and we're going to talk about that because of Qt and QML. So what's new, right? This is a Qt thing, and that. Lots of rants, so you can go check out the link and read up on them. And so it is a Qt thing. It's them being very clear. I wouldn't say finicky, just being very clear about, well, no, it's not exactly what we do, and that. When they're talking about this, they're really not talking about this macro view of the application. They're really talking about this micro view of how their controls work, how their buttons, how their drop-down lists work, right? And so what they typically do is they revert back to this hot sticky mess, right? View controller. In that, but introduce this thing called the delegate, and that's what gives them this flexibility, okay, in that. And delegates can be swapped out on the fly, and so then that gives you, for them, right, they're just trying to be clear about what they've done in the back end for their controls. Again, this micro view of controls within the application. Lots of communication via signals and slots. Slots are, in the event world, signals are events, and slots would be event handlers and that sort of thing. So lots of communication that way to deal with any kind of latency and that. Signals mean events, slot means event handlers. This could be a techno-weenie debate, but it's really about them being clear about, well, no, that's not really what we did. So that, they kind of fused the view and the controller together, but then added this layer called the delegate, which gives you the flexibility and that to present the model in many different ways. So in MVD, the model informs the view about changes to the data and data sources, right? The view captures the user's interactions. A human clicked here, swiped there. Signals from the delegate inform the model, right, and the view, right? So although they might have fused the view and model together, they put this extra layer on top, right, that will allow you to be a little bit more flexible. And so the signals from the delegate also get involved in the state of the editor. So this is the idea that you're working with controls where you're making changes. Probably the best one to visualize in your head would be some type of table control. This is a classic example. So it'll be some type of table model. And so in that sort of scenario, what we're talking about is a control, not so much the big picture macro application, but the micro picture of this little control called a table control that has rows and columns where a user might be inside a cell changing a value, much like you would be changing a value in a spreadsheet. You know, how is that all tied together with the backend objects that get saved eventually to disk somehow, and you making a change through the control, that getting saved back in the object, back in the model, and then after it's saved, the view being updated. So, you know, think of someone editing, think of someone adding rows, changing cell values within a row, that deleting rows, and all the signals that would get fired off, you know, this row cell value changed or something, or updated, and responding to that, right? So they're just trying to be honest about what they did with their control classes and objects, in that they actually fused the view and the model, but then added this extra layer called the delegate, which allows you some flexibility. So what we're going to do now is sort of jump into an area just to refresh us and reinforce some of the things that we've been talking about. So we're going to talk about the user interface, the UI, right? So we'll take a look at the Java FX user interface. So this doesn't have to be this way, but we're going to take a look at, well, what if you're doing FXML, we're using Scene Builder, and that sort of thing, right? So you could, if you wanted, design the interface with code. However, right, that's a hot sticky mess we want to avoid. Let's say we're using FXML and we're using the FXML annotation and the FX IDs in Scene Builder, right? What we do is the interface is not, even though the code would be written in Java, the things that respond to people clicking and swiping and changing values in the list, the user interface was actually specified in a specific XML language, FXML. And so the interface is actually written in a completely different language than the code that responds to people clicking. So that way it's done at the physical level. It's physically a different file. It's physically a different language. And therefore we have clear, distinct, hit you over the head with a bat separation of the view, the user interface, and the data in the model. Okay, there's this controller class, and we saw it, main stage controller from 7010, written in Java, different language than the XML language in FXML, right? So the total number of languages you would have to know to do this, 2, okay, and that sort of thing. So you know, right? So here, I'm just pointing out this is main stage FXML. Right, there's some sort of text area and that sort of thing. In that, there's a menu bar and a menu item. Notice that there's these angle brackets, question marks. We see border pane, angle bracket. So it's very much a tag, what's called a tag language, much like HTML is a tagged language, and that sort of thing. And then this is what the controller looks like, and therefore we have main stage controller, and all of a sudden look at this, it's Java. We got curly braces versus angle brackets and that sort of thing. Commenting is done differently in that, and so we're in a completely different world when we're in the controller in the code. And here's main stage, the thing that launches it all. There's the one line. If you take a look, parent root is equal to fxml loader.load, and go get that file on disk in that different language and translate it into code into a user interface. And so then there's the classic HTML5, no front end framework on this and that, and so the interface is not designed with code, so it's not done in JavaScript. So we're talking HTML5. One of the big lies I told you about in 7.132 is that, you know, the HTML5, the big thing, well, it's not. The big thing is it's not. The big thing is not HTML. The big thing is cascading style sheets and JavaScript, right? Two other languages, right? So the interface is usually spec'd out, right, in some combination of HTML, or as we saw in Node, Jade, which gets converted to HTML. There's also some cascading style sheet for styles, but what you find is there's a lot of stuff going on in the CCS world in terms of how your interface is organized and how it uh, shifts on the screen and that sort of thing. When we're looking at the responsive frameworks earlier in the course, in that with Flexbox, there's lots of stuff happening there. But again, HTML, tag language, cascading style sheets. It's a markup language, but it's a very curly brace colon kind of language. So again, a different world, right? And this is just the user interface. We haven't got to the code yet. And then the controller, if we want to call it that, is someone clicks on a button and we run some JavaScript function out of a file somewhere. And so we're responding to an on-click event of a button or some other type of control. A complex version of this, right, would be the above HTML and cascading style sheet, but maybe making some AJAX requests back to the server so that we're only updating part of the page, right? We hook a callback in, and we check the response status, which would then calls another function, right? That's typically how it goes. So before you fire it off, you have the hook into a callback. When their server responds, you check the status. If it's a good response, hey, you don't want it to be a 403 or a 502 error or a 500 error. So if it's executed well and we got data coming back, and then we call another function to figure all that out, right? So what are the totals on this? We can have lots of arguments. It's 3 to 4 different languages, right? And maybe 3 functions to make it all happen when we're talking about callbacks, right? There's one to initiate it, and there's one to check the status, and then when it's good, there's another one to process a good result. That's your 3 functions. But your 3 to 4 languages, we're talking, it could be HTML, cascading style sheets, and JavaScript 3, or if you're in the Node world and using the Express framework, then we're talking J gets dropped in, and now we're at 4. Throw some XML in there, maybe we get into 5, and that sort of thing. So it's interesting is one way to describe it. And so this is an example of out of one of my other courses. We have the view on the one side, which is sort of a stack frame for the controls, and it has placeholders for that we can use as hints. Works really good in mobile and that kind of stuff. So that's what it looks like on the left. The reality is we have some HTML, but notice that near the top the HTML is referencing style sheets in cascading style sheet language, which is in another language. So there's lots of angle brackets in here, and that lots of quotes, right, double quotes and that sort of thing. But then in the Jade world, this is what it looked like in Jade. Notice in Jade, for me anyway, lots of parentheses, so things definitely change. No angle brackets to be seen, more parentheses in that. Still got lots of double quotes in that. Not too many colons, right? In that. So that's how I can tell what language I am in, is what kind of characters I see. But then there's going to be, this is cascading style sheet, right? I believe this is part of the pure cascading style sheet that does the stacked layout that we saw with the controls before. And so, okay, lots of angle brackets, lots of colons, right? Lots of square brackets. Kind of feels like JavaScript, but not quite what you're used to seeing. Could it be JSON? Nah, it's not quite JSON. There's still some weirdness there, right? So it's not quite JavaScript in that. So yet another language. And of course, this is the JavaScript that would respond to someone submitting a form or clicking on something or something like that. And so here we see words like function, and we see var, and we see more equal signs, right? Less colons, right? And that's a lot of more semicolons, some curly braces in that. Yeah, so yet another language. And this would be more of the controller class controller concept or presenter concept that is responding to those three other languages of HTML and cascading style sheets and that, and others as well. Jade if it's involved. So I want to talk now about the Android UI. We don't do Android anymore in this course. We're doing QML, but they definitely separate the view and the code. So in Android, if you use Android Studio and you design an app, your interface is not designed in Java code. It is designed in XML. So the interface in terms of the user interface and portions, because you can have something called like XML fragments or XML frags that make up a bigger interface. Even you may have an app that has lots of tiles in that, but you might find a fragment of XML in the project that just describes how something looks, how a list element looks. So not the whole application is about slide out drawers and toolbars and stuff, but in a list, how do you want the information in that list to be organized? Maybe you want an icon right at the front, and then some bigger text and maybe some smaller text like a subtitle and maybe a checkbox on the end. So all you're really doing there is describing how one item in a list might look, and that's your XML fragments. But definitely lots of XML. XML for settings, XMLs for the interface, XML for styles and colors in that. They even organize it all in a directory called layouts, right? They have a separate directory where all the interface files go, right? If you have like a complete file, not a fragment, you have a whole activity, it's called, partial things that just describe one thing within a list or one thing within a grid layout, right? There is a controller class that typically is paired with that at the activity level and that's written in Java, different language than the interface, right? So here definitely two languages. There's XML, right? But even within Android, there's a couple things. There's different XML for settings. There's different XML for permissions. There's different XML for the layout of the user interface. And then there is Java code for the controller class in the background. All right. And a lot of that XML gets converted into a Java object called R for the resource folder. So there is a resource folder with a layout subdirectory. And typically you make changes in the XML that gets compiled into this class called R. And that's how you reference things on the interface. R dot this, R dot that. And the dot usually gets to an ID, and that ID links to a particular thing mentioned in XML, much like an FXID tag in JavaFX. So this is a simple activity. And that would be an application on your phone in Android. So this is what the interface is. It's using a constraint layout. It's got a text view, which is like a label in that. And it's got a bottom navigation bar and that sort of thing. But here we are, angle brackets, classic XML being used to specify the particular layout of the application. And then you have a main activity class, which is typically paired with that XML if it's a full complete file versus a fragment. And here we see Java code. We see words like private. We see more angle brackets, braces versus angle brackets. We see traditional programming structures like a switch case statement and that. A lot more equal signs, by the way, when you're in code and that. So here we'll talk about QML user interface just a little bit. So how does this new thing called QML compare to those others? Compare to JavaFX, compare to the web, compare to Android. So the interface is designed with code. Okay, well that's different, right? So that sort of thing. The code is called QML. QML is a blend of what I call JSON looking stuff in JavaScript. Just remember that JavaScript can look very different. We talked previously about these different styles of JavaScript, right? To the point the styles are so different you would swear that you're not looking at the same language. But unfortunately, you are, right? And that sort of thing. So we could totals, it's one language, right? Technically, but definitely two different styles in that. And so the user interface is typically done in this JSON style, and the code that the slots, the event handlers that respond to the event being raised, this thing called the signal, right? That's typically written in the old school function style, right? So simple is sometimes best. It's like full circle, right? This is how we used to do stuff, and then we separated, and now we're coming back because, okay, no, we can now still do the separation, but still be in one language if you want in that. And I guess that is the interesting part. We can still have this MVC, MVD, MVP, or MVVM kind of look at life, but we can still do it with one language, right? Which makes it a little bit easier on the developer in that they just have, to master one language. So here is a QML user interface, right? And so when we look at this, we got this thing as a column. It's used as to help you lay out controls. We have a thing called a button, right? That button has an image on it. There's a lot of nesting going on here. And then we have on click, right? And so when someone clicks on this button, right, what do we want to happen? So this is very much a JSON kind of feel to it. Now you could have a mix of a JavaScript function. You'll see this in lab when we're working on the assignment, that we can switch to this different style. Technically the same language, but a different style in terms of, you'll see the word function, you'll start to see more equal signs, you'll see less colons in that. But again, we're still in the same language, fortunately or unfortunately. So if you need to re-examine a topic or need clarification on a term or concept, or just have a question, you can get an answer by posting a note on one of the discussion boards for this course. This concludes this lecture.